Hello, welcome back. Today we're gonna do one of my favorite lessons, one of my favorite topics, and that's trig identities. So we're gonna start with co-function identities. Now we have this triangle here, and we know that whatever this angle is going to be 90 minus whatever this one was, whatever the red one was. So for example, if theta is 40, then 90 minus theta would just be 50, right? So let's decide, let's say we want to use these numbers. And I'm just going to call these sides something else. So um, let's go with CBA. So if I want to know sine of this red angle, it's going to equal B over C. And cosine of this red angle will equal A over C. Sine of the blue angle will give us A over C. And cosine of the blue angle will give us B over C. So if we notice, sine of the red angle is the same, has the exact same value as cosine of the blue angle. And cosine of the red angle has the same exact value as sine of the blue angle. Well, this is one of the things you should kind of learn through pattern and doing it over and over, but sine of any angle, let's call it x, is the same thing as cosine of 90 minus that same angle, and vice versa. And notice the red was just this theta, and then the blue was 90 minus theta. So I'm just replacing theta with x. And there are a bunch of other ones that we're going to talk about, but this is the general idea. And normally you won't see 90. You will see pi over 2. So the problems you guys will see, it's going to be pi over 2 instead of 90. And pi over 2 is just 90 in radians. And so you should copy this chart in your notebook. So on this slide, we're going to talk about the fundamental trig identities. So we have reciprocal, quotient, Pythagorean, and odd even function identities. And I'm not going to go through explaining how we derive all of these, but from here, we can get these two things. And then the even and odd functions just have to do with symmetry or relations of symmetry. But that's a topic for another video. But all of these identities should be written down somewhere. You will need them most likely for every problem that you're doing in ALEKS. So let's say we have a problem like this, and we're asked to simplify this. Well, to simplify this, we basically just have to apply whatever we can. So we're going to use these reciprocal identities. Well, cosecant is the same thing as 1 over sine. Sine just kind of stays the same, but sine is just sine over 1. And then tangent is just sine over cosine. So all this I got from this top part right here, the reciprocals. So now we want to simplify this. Well, 1 over sine times sine over 1, these two things cancel out, these cancel out, and we're just left with 1. So when everything cancels, you're still left with 1 because you're dividing a number by itself. So 1 divided by sine over cosine. And when we divide fractions, we keep the numerator, change the sign, and flip the denominator. So this becomes cosine over sine. And cosine over sine, if we look at the table or look at the quotient identities, sorry about that being messy, is the same thing as cotangent. So cosecant of theta times sine of theta over tangent of theta is all equal to cotangent of theta. So I think it's interesting how everything over here, with all that it is simply equal to this part over here. And sorry about being unorganized, but we're going to practice this more in the next problem. All right, so in this problem, it says complete the proof of the identity by choosing the rule that justifies each step. So they show the work, but you have to determine basically the step that they took. So basically this is true. We know this is true, but they just showing the proofs, kind of like in geometry. So the first thing they did, they from here to here, secant squared x minus 1 became tangent squared x. So that's the only difference that I see. Cosine is still the same. Well, if we look at this Pythagorean identity, tangent squared u plus 1 equals secant squared u, we can manipulate this if we subtract 1 on both sides, right? We'll get tangent squared u equals secant squared u minus 1. So even though it wasn't necessarily here, we can manipulate these three things. So basically, that's how they got tangent, because this part equals tangent. So we know this first one is the Pythagorean rule. And then from here to here, again, cosine stayed the same, but tangent became sine over cosine. That looks like we used the quotient rule. So that's what they did here. They used the quotient rule. So now we have, if we look, we see that this cosine on the bottom is not there, and this cosine is written differently. Well, what happened was sine squared, cosine squared. This cosine squared basically means we're multiplying this thing twice. So if we have cosine divided by cosine squared, this is cosine divided by cosine times cosine, and one of them will cancel out. You'll have 1 left on the top. And I forgot the thetas, but forgive me for that. So that's what happened here. So we can just, that's not any rule, that just is algebra, which will be one of the options you can choose. And then 1 over cosine is the same as secant, right here. So this is a reciprocal identity or reciprocal rule. All right, so this problem says prove the identity. So this time we actually have to work out the problem and provide which rule we use. So we have to do the work and explain how we got our answers. So we have 1 minus cosine squared theta times cotangent of theta, or it's actually x, equals sine x cosine x. So the proofs we did in geometry, where you started with something and you had to get to the ending, this is our ending. This is our ending, sine x cosine x. So we have, make sure I got some space. 1 minus cosine squared x times cotangent of x. We don't see 1 minus cosine squared x anywhere on this formula sheet, but I do see sine squared u plus cosine squared u equals 1. If I subtract cosine squared u on both sides, ooh, this is terrible. You end up with sine squared u equals 1 minus cosine squared u. So 1 minus cosine squared x is the same thing as sine squared x. Right? Okay. So we got that. Now, that was the Pythagorean rule that we used. And sine squared x we can keep because we can't really do anything with that. But cotangent, we can use quotient identity. So this becomes sine squared x times cotangent is cosine of x over sine of x, right? Okay. And this was the quotient rule. So now we have sine squared x cosine x over sine x. And we have two sines on the top and we have one sine on the bottom. So we basically subtract these exponents the same way we do in regular algebra. And this cancels out. So now we just have sine x times cosine x, which was the answer we were looking for. So that's what we got right here. Sine x times cosine x. And this last rule was algebra, or this last thing you would put would just be algebra. So hopefully you can see that there is some level of critical thinking that you will need in order to do these problems. Sometimes you'll have to manipulate what's on the formula sheet. Sometimes you kind of have to be creative in how you go from one step to the next. So try out those problems on Alex. If you want extra credit, you're going to create your own true equation. So notice I said true because there are times where there is no solution or it may not work out. So create your own true equation using the reciprocal, quotient, and Pythagorean identities. So they need to include all three of them. And write it down, send it to me, email it to me for extra credit.